Yes, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In our discussion, we are going to look at the general characteristics of group 2 elements. Now, in our first discussion, we had seen where this specific group of elements are located in the periodic table, and we had said that they are going to display various characteristics, of course, which we are going to generally refer to as characteristics being displayed by metallic elements. Now, in this case, we understand that these are going to fall under the category of the S block elements, which are going to consist of a charge of a positive 2, and then we have said that these are going to have the S, of course, orbital, which is going to consist of 12 valence electrons, and of course, this is going to give them the characteristics of these specific elements we refer to as S block elements. Now, in this case, I mentioned that we can regard these elements as alkaline earth metals, and this specific substances that we are going to refer to as earth metals, being given this name due to their inability to decompose on heating, and this is where they, of course, attain this specific name of earth from. Now, in this case, we are going to look at the concept of solubility, whereby we are going to see that these specific substances are going to be undergoing some of the reactions, and they are going to form some of the compounds which we are going to see being such as carbonates and sulphates. Now, unlike other elements which are naturally found in their, particularly in their elemental state, we are going to see that this specific majority of these specific elements are going to be found in terms of carbonates and sulphates. And of course, I can just list them. This ranging from beryllium, of course, we have magnesium, calcium, and then we have strontium, barium, and then lastly, we're going to have, of course, radium given as such. So this is a range of group 2 elements, of course, according to the specific arrangement of the periodic table from the top to the bottom. And we're going to see that these specific elements are going to display some of the unique properties, especially, which I've said, especially majority of them are found as carbonates and sulfates. Now, in this specific sense, then therefore, we're going to see that some are going to be slightly soluble in water, and of course, they're going to form basic solutions, which we are going to see in terms of equations. Now, like group 1 elements, these are going to be reacting with acids and water, as I mentioned earlier. And some of the heavy compounds of this specific group, like the calcium, strontium, and of course barium and radium, they are going to be nearly as active as group 1 elements, as we had said. Now, we had said generally that these groups of elements are going to be reactive, but less reactive than group 1 elements. But this last category of elements, which are more heavy, are going to display some kind of reactivity, which is relatively the same as group 1 elements. Now, we're going to see some unique characteristics being displayed by barium in its compounds as compared to the rest of this group of elements, whereby barium is going to be outstandingly different from this other group of elements in terms of reactivity, especially with air and water, which we had mentioned. Now, in this case, we're going to see that barium basically is going to be unreactive with air and water, like these other compounds which we had given as general characteristics. Now, barium oxide is also not going to react with water as other group of compounds, oxides, are going to do. And of course, we're going to see that this other group of metals are going to form metal hydroxides upon reaction with water, which are going to have a general characteristic or a general form which I've just given on the board. So in this particular case, this is going to be in contrast with beryllium, whereby we're going to see that beryllium and the beryllium oxide are going to dissolve strongly in basic solutions to form a complex ion. So this is going to be beryllium oxide in basic solution, and these are going to form a complex, of course, a salt which is going to be given in terms of this specific ion. So therefore, we're going to see that this is one of the unique properties being displayed by this specific element of barium. And for the halides of barium, for instance, if we have the halides of chlorine and fluorine. So let's take this one for X, implying chlorine and fluorine. And of course, these are going to be barium, of course, a halide of these two specific compounds. These are going to be poor conductors of electricity added to their covalent nature. We say that the ionic character is going to be the one responsible for conductivity of electricity, but due to the covalent nature of these specific halides, which are basically barium chloride and barium fluoride, they are going to be covalent in nature, and therefore they are going to display this aspect of poor conductivity of electricity. And of course, we are going to see that for the formation of ions, which we have said, which are going to have a positive or a charge of positive 2, barium also is going to display a unique property, only that it's going to be slightly forming these barium positive ions due to the aspect of this covalent nature, which we have said, which is going to be predominating its chemical characteristics or chemical reactivity. So therefore, this is going to form a barium 2 positive, and of course, which is going to be slightly forming, unlike other ions, due to the covalent nature, which is going to be predominating its chemical activity. And the concept of a barium oxide, which I had mentioned, of course, this is going to be amphoteric. We had mentioned about this specific term in our description of acids and bases of amphoterism. So it's going to be amphoteric in a sense that it's going to display this aspect of acidity and basicity. And therefore, we can just illustrate this one by using this one. So it's going to be amphoteric in a way that, unlike other group 2 oxides, it's going to display this specific characteristic. So if we have a barium oxide, and this is going to be added with water and hydrosonium ion, which is basically going to be given as such. This is going to provide a complex ion of beryllium. Of course, this is going to be water, not hydroxide. So we're going to have a complex ion of this specific nature. And then we are going to have 2 positive given as such. So the reaction that is going to be given as such is going to display these specific characteristics of amphoterism for this beryllium oxide. And as well, we can give a second version of the equation apart from this first one in order to confirm these specific characteristics, whereby we are going to have this one, of course, reacting with a base in order to form another complex negative ion given in terms of BOH4, and this is going to be 2 negative given as such. So these are going to be aqueous products formed or ions. So therefore, these 2 equations are going to be giving us the concept of amphoterism, which is being displayed by beryllium. And of course, as we said, as we can see from this, is going to react with aqueous acids to give hydrogen gas and other ionic compounds, a property which is going to be displayed by beryllium. Now, in our next discussion, we're going to look at some of the methods of production of these group 2 elements. But the general properties which I've mentioned, of course, are going to assist us distinguish between the group 2 elements in terms of their oxides, and of course their ability to be reacting differently, especially beryllium, which is going to distinguish itself from other elements which we have seen. And of course, the higher elements or heavier elements being displaying, of course, the properties of group 1 in terms of reactivity. Now, in this particular case, we are going to look at some of the methods of production, and perhaps in terms of abundancy and some of the tests we can perform in order to ascertain or confirm the presence of these group 2 elements. So that is it for now. Kindly check our description boxes for various links of other videos which are going to assist us understand this specific group of elements better. So that is it for now, guys. Bye, God bless you. Catch us in our next video.